Okay, Physics fans, Physics 12, Momentum 2D, questions on page 91, 92. That's the review of the chapter of 2D, last questions in Momentum. And there's about 5 there that I want to go over. And the hockey one that I assigned here, it's just 2 hockey players colliding. One has a mass of 82 traveling north at 4.1. The other one has a mass of 76 traveling east. They therefore meet at a right angle. Makes it really simple. There's no components except for the ones that are just basic ones. He has a momentum of 258.4 and this guy has a momentum of 336.2. So when they tangle and move off together, you just have to add those 2 components up vectorially, Pythagoreanly. And so the total momentum, as I said, in x and y is this. Pythagoras tells us this. SOHCAHTOA gives us the angle there. The total mass of them together is 158. So you get the total momentum at that angle. It'll be north of east. And then you divide that by the mass, and you get the final velocity. Okay, pause it definitely if you need to go over it. Copy it down. Here's number 2. Very, very, very similar question. A truck is heading down at 4 meters per second at 6,000 kilograms, so its momentum is that, and a car is 2,500 kilograms traveling at 6 meters per second, therefore its momentum is this. They stick together, so they stick and they will travel off, so you just add these 2 momentums together and put it together. So their total momentum Pythagoreanly is 28,000. The angle is 58 degrees south of west. So you combine that together to get the momentum, and then divide it by the total mass. The 2 vehicles added up is 8,500. So the speed is this, and the angle is that. Okay, next question, number 3. A lot harder because we don't actually have the angle, but here we go. One piece flew off 90 degrees to the other. One piece is at 0.2 kilograms and it's 20 meters, and the other one is 30 meters per second at 0.1 kilograms. So boom, boom. I just kind of went west and south. Don't have to. You'll see why in a moment. I just chose it 90 degrees. So that's the total momentum of the third piece. Will have to have enough to make it 0. So this one will have to have 4 because 2 times 20, 0.2 times 20 is 4. And 0.1 times 30 is 3. So this red object that I've drawn in dotted red will have to have a 4 and a 3 in the opposite directions just to have the total momentum of the system remain 0. So Pythagoreanly, it's 5, 3, 4, 5 triangle, angle is 36.87 degrees. Now, how do you label that? Okay, you could just do that north of east as drawn, but since it didn't say that, you would have to say, you'll have to label the angle, this angle. And that is 126 degrees from the 0.1 kilogram object, or you label this angle, or do them both, 143.13 degrees from the other angle. And you still have to write down that this momentum is 5 kilograms meters per second. And then your angle could be this. Okay? And then if the mass of that third piece, so notice that we didn't even need the mass of the third piece until now to find out its velocity, because it was just momentums. Interesting part of it. And then just had to divide by the mass to get its speed. And again, its speed is 33.33, but we can just use that angle or use that angle, or just north of east as drawn. Okay, we're not going to go over number 4, but we will go over number 5. This is probably the hardest one of the bunch. Now, because there's 2 planes, one's flying due south, and its mass is 0.4 and it's 20 kilometers an hour. So its momentum is 8 kilometers per hour. I decided not to convert because it will just all cancel out. and that's just due south. The other one, lots of tricks in here, lots of little things, east of south. So it's 20 degrees east of south, which is 70 degrees south of east. So its momentum is 12.5. Putting it in there, we get its components of the x component of that green one that I've drawn here, and its y component. And we have to add that up to get its total momentum. The total momentum beforehand. And the total momentum in the x is only this one. And the total momentum in the y is these two together, the two y's. So it's 19. Pythagoreasly, it's 20.2 to 20.2. The angle is 77.78. So that's its momentum, still in the units of kilograms, kilometers per hour. But I'm just showing you that once we divide it by kilograms, the kilometers per hour just comes right back out. As long as you put whatever units you put in to momentum, or the units that you get out, it'll be fine. And you get the velocity of the collision as that. Pretty sweet. It's a little bit harder because you have to do the components, and I love it. This is the best question there was. Hardest one. Do I always think the hardest ones are best? I don't know. And number 6. What impulse is needed to change the velocity? So impulse is the change in momentum, which is mass times the change in velocity. The initial velocity was 3.6 north. The final velocity was at 1.2 meters per second, 45 degrees north of east. So definitely slowed down quite a bit and also changed directions. So to slow an object that's moving upward, you'll have to push down. So the force will be south. And you'll have to push it a bit east. So south of east sounds good as an answer, although we just snuck in the answer peak over there. So we break the 1.2 into its components, and it's a 45 degree angle, so the components will be equal, 0.8485 meters per second north. And these are just its velocity components. We could have done its momentum coordinates components. And if that's the case, just multiply this by 90, each of them. But I'm just doing velocities. And I get the total change. Okay, so I'm going too fast. Here we go. And initially it's going up at 3.6, but then at the end it's going 0.8485. So how much did it change? It changed south by 2.751 meters per second. There's my work here if you want. Final minus initial is the same as final plus a negative initial, and a negative initial is positive 3.6, and now becomes south 3.6. And now if we add that up, anyways, it makes sense as you follow through my work if you didn't. And then so the change is 2.75 down and 0.8485 east. So Pythagoreasly join them together, and you get 2.879. You multiply that by the mass, and you get 259.1. And units of either kilograms meters per second or Newton seconds. That's for impulse. And that's what it asks for, the impulse. It is a vector. There you go. Pause them as you need to go over any of the questions. Dun, da, da, da. Here comes the jingle.